Hello everyone, my name is Kieran Mullins and today I made a presentation on circuit board manufacture and design and I'm just going to run through it. This is going to be just a quick summary of how a PCB is designed and manufactured, and I won't be reading every piece of information on each slide because there's quite a lot, but if you want each step to be presented in further detail, then I'd recommend pausing the video and having a read through it. But I'll just be quickly summarizing these slides, so let's get into it. Now, the introduction. Circuit boards have many different variations, such as through-hole, surface mount, and mixed technology, which means a mix of both. Now, through-hole means that the components are slided through holes on the board and soldered on the other side, while a surface mount board will have components being soldered directly onto the surface of the board. Now, these two different types have their own advantages and disadvantages, but personally I use through-hole a lot more because I hand solder, and through-hole tends to be a stronger connection, but in manufacture you can easily mass produce more surface mount because of wave soldering. Now, typical circuit board applications, multimedia devices, so your phone or your laptop. Computing, obviously, household electronics, and aerospace. Now, as you can see here, different applications are going to have different types of circuit boards. Some applications may have boards that are very rigid or flexible, depending on how much shock the application is going to go through. And whether or not these boards are multi-layered or not just depends on the complexity of the application. Now, when making a PCB, many characteristics need to be taken into account and justifiably calibrated, so physical size and component density, composition, ease of mass manufacture, component availability, and so on. Now, how is it produced? I'm going to be going through the 6 summarized steps of circuit board manufacture. So, artwork production, chemical processing, solder masking, silk screen, drilling, and punching, as well as scoring. Now, step 1, artwork production. This involves the software that has the specifications for the circuit board itself, and these pieces of software are called Gerber or Gerber, whatever you prefer, format files, and they're uploaded into CAM, computer-aided manufacturing, for the manufacturer to view, and they're always available, and they're important because they hold basically what the PCB is supposed to be. It has the precise specifications for the manufacturer. Step 2, chemical processing, exposure, developing, electroplating, and etching. So as you can see here, material used in PCBs is flame retardant for fiberboard because it's important to have flame retardant materials as these boards tend to go through heat. Exposure just involves PCB image transfer, as you can see, and involves selective removing of the material in order to expose the copper rails. We'll have high sodium hydroxide developing on the PCB, just gets rid of any impurities. Electroplating, which is interesting because it coats the PCB in metal, which can provide through-hole connections, but it can also increase conductivity, which is really helpful. And finally, etching, removing unwanted copper to make your rails, basically. And of course, after this chemical processing is done, the board will need to be cleaned because you can't just have chemicals all over your board. Once again, if you want to view further detail, just pause the video and have a read through. Step 3, solder mask over bare copper. A board will have an epoxy ink solder mask printed on both sides. It prevents any unwanted connections on the board, so just stops solder from bridging over for where you don't want it to be. and the rest of the slide just goes into detail about how this mask is applied and how it's processed, tack drying and so on. Step 4, a PCB needs to have a silk screen, which is basically a component guide that shows the manufacturer where each component's supposed to go and in what orientation. And it's a necessity, really, and you can view it in the Gerber or Gerber format file. Step 5, drilling. Pretty self-explanatory. Any through holes that need to be drilled into the PCB are done with a drill. Now, this will typically be done not by hand. Well, not that you couldn't do it by hand, but typically you'll have a machine doing it that's operated by an operator, and this machine will use precise X and Y coordinates to ensure that the drill holes are done perfectly, because if you're off by even a millimeter, you could be affecting the functionality of the board. Step 6, punching and scoring. Now, this involves as you can see, a blade that is perfectly shaped to punch out each individual PCB, because in mass manufacturing, we'll have all the PCBs sort of together on one large panel for just manufacturing processes, because it's easier to process one large panel rather than just having to process each individual PCB, because you'd be there all day and it's just not efficient. Now, how's a multi-layer PCB produced? So basically you'll have these glass cloth sheets pre-impregnated with epoxy resin and thin copper foil. Now, all the layers are going to be heated and pressed together, and when it's cooled after being pressed together, this hardens the epoxy resin, and basically it forms a lifetime connection between the layers, so it's a very strong bond and it's very helpful. We'd use, again, multi-layer boards in a very complex PCB, because the more layers you need, obviously the more components you need. Now, I've chosen to further research through-hole and surface mount boards, so I'm just going to go into more detail about it. So the component mounting method, soldering method, and quality control. Now, I've already explained how a circuit board is manufactured, so if that's all you're looking for, feel free to click off the video now. And yeah, but in the next slides, I'm just going to go into a bit more detail about the surface mount and through-hole boards. Now, surface mount technology boards manufacture, they go through automatic screen printing involving a solder paste being applied to the PCB, an automated pick and place machine putting the components on the boards, an oven reflow machine which solders all the components at once, and an AOI machine which is good for inspection. And as I said before, as you can see here, surface mount is just really helpful in manufacturing, as you can get a lot of the steps done really quickly. And finally, through-hole boards manufacture. The components are manually inserted. As I said, for hand soldering, this is typically stronger because you've got components actually going through the board and being soldered on the other side. This is the end of this presentation. I hope you enjoyed it. I hope it was thoughtful, and hope it was useful, and please consider subscribing. Thank you.